Okay, this is my MakerBot Replicator 2X. I've had this almost a year now, and I decided I had to hack it a little bit. What I wanted to do was be able to accurately, very quickly see exactly what the machine's doing in respect to its axes movements and so on. So what I did was went in, I added another processor board here. This is a Parallax Propeller board, and for anybody who's familiar with Parallax, they make a chip that has 8 processors, individual cores, that is ideal for doing this type of a project. So this is the main board here of the printer, and each one of these green boards here are stepper motor controllers. And what it does is the main processor, which I believe is right here, sends out commands to these boards, and those boards handle the stepping functions, the actual control of the coils within the stepper motors. So what I decided to do, because I don't have access to the actual processor that's running and how it's running what it does. Sorry about my focus here. Can't seem to get it to get into focus. Anyway, what it will do is have a step pin and a direction pin. So if it wants to move the stepper in one direction, it'll set that pin either high or low, and then it'll pulse the step pin for each step that it wants to go in that direction. The little controller handles all the current, and the some of these steppers are set up to be micro-stepped and so on. So we don't really care about that. As long as we know what the resolution of the final movement of the motor is, then we can determine how far the motor is moved and in what direction. And we also have 2 extruder controllers here, which are basically the same exact controller. They work in the same way, depending on whether you want to send the material either extruded or actually pull it back and retract it. So at this point we're watching those, and then we're also watching the end stops, which you can see some of the wires I have connected here. These go out. These 3 here are for the end stops, and that lets me know when one of the axes has reached the end of its position, and typically it's the home position. So we then take all of these cables, route them in. We have a protection resistor for each one, and we go into the processor here, and it watches these for pulses. So just capturing the pin pulses is only one part of the equation. You have to be able to put it all into context. So anyway, this is the hardware side of it. The next step of what I'm thinking of doing is tying into this cable, which is the cable that goes out to the front panel, which is the LCD and the buttons. And my theory is, if I can intercept those signals going to the LCD, I can mimic what the display is displaying, which will then allow me to know when I'm starting and stopping a job and what my statuses are in that. And this is pretty much an exercise in how to get data out of a machine that was never designed to give you information. And it's one of the things I do for a living, so for me this is just some fun. Anyway, I'm going to pause here and I'm going to show you it in action. Okay, now we're done with our first layer and we're going on to do our second layer. Actually, we're doing a filler in our first layer. Now we're on to the second layer. Now, as we can see here, our speeds now have increased quite a bit. Some of these are movement speeds, so I'm going to wait till we get, you can see in the movement speeds we're doing 150. Now this is outer layers. We did the first one looked like about 90, now we did this one at 80, and the last one at 60. So there's 3 shells. Okay, so now we're doing quick fills, and you can see that sometimes it jumps up to maybe 80, 85, 90. What that's indicating is that it's not getting a long enough movement. As you can see here, we're not doing a very, now we're on to longer movements. Let's see what we're doing here. So we can see now we're hitting 80, 85 or 90 more reliably, more frequently. And that's just showing acceleration in when it's actually working. Now what I don't have on here right now, this is just a textural interface. This is just my first pass at getting the data out of the microcontroller. What I want to do is send this to a dedicated application instead of a terminal program, and actually display this information more in a graphical, almost like a chart that shows the acceleration as it's ramping up and going down. Right now we're calculating speed about, I have to look at the code, but I think it's somewhere in the process of at least 10 to 20 times a second. I'm ascertaining the speed. And what I do to get the speed is I don't really even care what direction the head's moving. I just take all the X steps regardless of what direction they're going, all the Y steps regardless of their direction, and then I basically do some trigonometry on it and calculate the distance between the two, basically using the hypotenuse theorem. And with that I'm able to get a pretty accurate speed, and this just shows basically the inner workings of the machine. It's truly amazing what these machines do, considering what they're being ran by. I mean, they're basically an Arduino that's an 8-bit processor, and so to be able to control this movement and everything is just phenomenal. Being able to see inside of it is pretty cool too, and that's why I did this project, because 3D printers just amaze me, and being able to see the actual inner workings is pretty cool. So my other goal is to possibly set this up with a secondary LCD display to give you some of that higher resolution data. The GUIs on these machines, or the UIs, are really an afterthought, and they take back seat to the operation of the machine. So these screens update fairly slowly because the processor they have just can't keep up and give you a really rich user interface and keep the machine running smoothly and accurately. So I'm not faulting the guys that have built these, the firmware. It's just truly amazing what they've done. I'm just trying to tap into some of that and create a more modern interface.